Hi, welcome to the video. So today we'll try to solve the problem of the day from Geeks for Geeks for 14 July 2024. So the problem statement is to so we are given an array which only consists either zeros or ones in any random order, and we are supposed to modify the array in place itself so that all the zeros are on the left side of the array and all the ones are on the right side of the array. That is, we should, when we are traversing from left to right, we should not encounter any zeros once we started encountering ones, right? All the left ones should be on the right end of the array and all the zeros should be on the left end of the array, right? Taking an example, if we are given an array like this 0 0 1 1 and 0, so 0 comes after we started encountering ones, right? So we have to move this 0 to the left side of the array. That is, all the zeros will come first and then only we start encountering ones while we are traversing left to right. So this is what we are supposed to do, and the constraints are we are supposed to do the solve this problem in O of n complexity and without any extra auxiliary space, and the size of the array can vary from one element till 10 power 6, that is 1 million elements, right? And each of the elements can either be 0 or 1, right? So let us try to come up with a solution or approach how to solve this question. So we'll be following a two pointer approach, right? We'll be starting from both the ends, right? I'll call the pointer which starts from 0th index as left pointer, and the pointer which starts at the rightmost end of the array as the right pointer, right? So we have two pointers, left pointer pointing to the 0th index and the right one pointing to array length of array minus 1, that is max index of the array, right? So for each element, what I'll do is, as long as we have when we are traversing from left to right, as long as we are encountering zeros, we are fine, right? We don't have to do much. As long as and when we encounter a 1, right, then if there is a 0 on the right side of that pointer, then we should swap them, right? So that we have all the zeros on the left and all the ones on the right? So what we'll do, from left we try to find a 1, right, and from right we try to find a 0, and as and when we have a case where on the left side we have a 1 and on the right side we have a 0, we swap them, right? And we keep doing this till the entire array is being processed, right? Once both the pointers meet, right, what happens? So you either, for the left pointer, you either encountered a 0 or you encountered a 1 which you already swapped with the 0 that was on the right side. So every single element that the left pointer has passed is either a 0 by itself or you converted that into a 0, right? So that is how you will be able to solve this problem, by traversing each element once only and without any extra auxiliary space. So doing a dry run here, so we start with something like this. So for the left pointer, the first element is 0, so nothing to do much, and we go forward. The second element is also 0, nothing to do much here, and then we move forward again. The third element is 1, so something to swap, right? So we come to the right pointer. So first element from the right is 0, so we have something to swap, right? So at this position we have something to swap, so swap happens, the 1 comes here, 0 goes here. So this is a situation after the swap, and then again the left pointer moves forward and the right pointer also moves forward. So there is nothing much to do here because left pointer and right pointer have met, so we just return the array. So as you can see, all the zeros are on the left side and all the ones are on the right side. So taking another example, let us take an array which has 1 0 1 0 1 0, like that, right? So we start again with the left and right pointers. So for the very first element it is 1, so we have something to be swapped, and for the right pointer it is 0, so we also have something to swap, and we do the swap. 1 comes here, 0 goes there, so it's something like this. And then we move forward. For the left pointer it is 0, so nothing to do here. And again here it is 1 again, so something to swap for the left pointer. And then on the right pointer it is 1, nothing to do here. We move forward, and here it is 0, so something to swap. So since we have both the elements to be swapped, we swap these with each other. So 1 goes here, 0 comes here, so it becomes something like this. We move both the pointers forward. So for the left pointer it is 0, nothing to do here. For the right pointer it is 1, so nothing to do here. And then again left pointers move forward, and it meets the right pointer, which means we have processed the entire array, right? So we just return the array. So as you can see, all the zeros are on the left side, all the ones are on the right side. Cool. So let us see how the code for the same looks like. So we are initializing the left and right pointers here, and then while the entire array is not processed, that is left and right pointers have not met each other, we'll do this, right? For each element traversing from the left, we check if it is 0 and we have not met the right pointer, then we just keep moving forward. Similarly, for the right pointer, if the element is 1 and we have not encountered the right pointer yet, then we keep moving forward. And if we encounter, let us say if we encounter 1 here and if we encounter 0 here, we'll come into this condition. If we have not yet crossed paths with each other, then we do a swap. This is the logic for the swap. So we are basically replacing the left element which is being pointed by the left pointer with the element being pointed by the right pointer, and vice versa, right? And then we just move the pointers ahead, and we keep doing this as long as the left and right pointers have not met each other. So yeah, this is the code. Actually I've submitted this already. Some issue with the mic in the previous video session, so I can just show you this. I'll just run. I've already solved this and just repeating this part. Yeah, since this is the second submission, I'm getting this error message. So cool. I hope you like the video, and as always, please try to come up with the approach by yourself and try to write the code. If you are facing an issue with the approach, then come and see the approach part and try to come up with the code by yourself. If you're still stuck with the code, then I suggest you to look at the code. So yeah, that's it for the video. So hope you like it, and let us meet in a next video. Thank you.